Good morning, Course 2. Today we're going to be completing Lesson 106. Yesterday's lesson was very long. Today's lesson is going to be kind of short, so concentrate real hard while we go through this. This lesson introduces something called a literal equation. And what that is an equation that only contains letters, no numbers. So it only has letters, no numbers. Now, we actually deal with these types of equations exactly like we deal with the equations we've been working with all along. So we're really not doing anything different. We're just having to deal with letters. So if you look on page 740, example 1 at the top of the page, they ask us to solve for x. Now, that's the one thing that's sometimes is different in the literal equations. They will tell you what variable to solve for. So here's our problem. X plus a equals b. Now we're going to deal with this just like we did any other problem. In general, ours would normally say x plus 3 equals 8. But instead here it's a plus b. So if this did say x plus 3 equals 8, what would I do with this 3 that would be here? Well, I would subtract it. And that's exactly what I do here. A minus a is equal to 0. And if I subtract it from this side of the equation, I also subtract it from this side of the equation. So this becomes 0. X is going to be equal to b minus a. And that is going to be my answer. Follows the same rules that we followed for everything else we've done this way. All right, so example number 2 also tells us to solve for x. And here's our problem. A times x is equal to b. Now this is the exponent x. It's so that there's a multiplication sign right in the middle there. A times x. So if we had a 2x equals 6, we would just take this and divide by the number in front, and that's what we're going to do right here. A over a is equal to b over a. So a over a is equal to 1. These cancel. So we have x is equal to b divided by a, and that's just our answer. All right, example number 3. They want us to solve for w. So now here's our problem. A equals LW. That's A equals length times width. Now this time they're asking us to solve for W. So locate your W. Okay, and this is not a 1, this is an L. So to isolate the W, I would divide this side by L and this side by L. So in solving it, I've got A over L is equal to W. Now, I don't particularly like to work with problems this direction, so I can just flip it. And it would be W is equal to A over L. And that is all there is to that. Now, we're going to go on to roots. So if you look on page 740 at the very bottom, they talk about a perfect square. So the perfect square of 25 has both positive and negative square roots. So if we do 5 times 5, that equals 25. But if we have negative 5 times negative 5, that is also positive 25. So they're talking about, there are some answers where it could be a positive number or a negative number. So x squared equals 25 actually has two solutions. It could have 5 times 5, or it could have -5 times -5. Okay. The positive square root of a number is sometimes called the principal square root. So these numbers right there, the 5, the positive 5 would be the principal square root. So when you're trying to find roots of things, you're normally looking for the positive outcome. The radical symbol, this is the radical symbol. Here we go, and I put a 25 in there. The radical symbol implies you're looking for positive. So this is the radicand. Means you're looking for positive answers. So if we're looking for positive answers, it does not include these because we're not going to have -5 in there. So looking at example 4. What are the 2 square roots of 5? So we're going to take the square root of 5 and put it here. And this is one answer. The square root of 5 is the square root of 5, and we haven't solved that one. But we also could have another one, which is the opposite of the square root of 5. That would be the negative. We have symbols that represent other kinds of roots. So using the radicand like this, normally if it looks like this, it means square root. If they put a 3 in there, that means it's a cubed root. And so what is a cubed root of 64? Well, it'd be a number times a number times a number times a number, 3 times. And if you multiply it out, you'd find out that is 4 times 4 times 4 is 3 4s. That equals 64. So the square root of 64, the cubed root of 64, I'm sorry, I said that wrong. The cubed root of 64 is the number 4. That's its. Now, would we say that -4 is a cubed root of 64? No, because we're not looking for negative numbers. And if we made this negative, all 3 of these negatives, look what happens. 4 times 4 is positive 16. Positive 16 times -4 gives you -64. So a negative won't work there. Look at example 5. A has the cubed root of 1,000. Now we know that 10 times 10 is 100, 10 times 100 is 1,000. So our cubed root would be 10 times 10 times 10. And so we select 1 out of here, bring it out. It's actually going to be the number 10. That is the cubed root of 1,000. Look at this one. This is B. Cubed root of 27. Well, we know that 3 times 3 is 9. 3 times 9 is 27. There is our cubed root of 27. We take one of those out of there, and our answer is going to be 3. So now we are up to our practice set, and we only go up through G. We'll work those out together here. Make sure you're doing your practice sets when you turn your homework in. They will help you be ready. So here's the practice set. A, it asks us to solve for A. And here's our problem. A plus B equals C.